Have you ever wondered, how did computers get as advanced as they are in today's time, where everything in life has a development? So let's go back to where this development started. On June 2nd, 1822, created by Charles Babbage, was the first mechanical computer. Yet they say that does not necessarily consider what they call a computer today. Charles Babbage proposed the first general mechanical computer, the analytical engine. In 1910, Henry Babbage, which is Charles Babbage's youngest son, was able to complete a portion of this machine and was able to perform basic calculations. On January 1st, 1936, the Turing machine was first proposed by Alan Turing in 1936 and became the foundation for theories about computing and computers. Jean Pardik and Francis was operating on the ENIAC's main control panel. Bartik was present on the day of ENIAC's unveiling to the world, and even helped troubleshoot a switch issue the night before the revealing. And we cannot let them be forgotten. On January 1st, 1938, the Z1 was created. The Z1 was created by the German Konrad Zuse in his parents' living room between 1936 and 1938. The Z1 was considered to be the first electromechanical binary programmable computer and the first functional modern computer. On December 1st of 1943, the first programmable computer, which is the Colossus, was developed by Tommy Flowers and first demonstrated in December of 1943. On November 13, 1966, the Department of Defense and Advanced Research Projects Agency contracted with the University of Illinois to build a large parallel processing computer, which did not operate until 1972 at NASA's Ames Research Center, the first large-scale array computer. Computing the speed of 200 million instructions per second. Wow. And about 300 million operations per second. And then about 1 billion bits per second. CDC's 6600 supercomputer, designed by Seymour Cray, performed up to 3 million instructions per second, a processing speed 3 times faster than that of the closest competitor, the IBM Stretch. The 6600 retained the distinction of being the fastest computer in the world until that was surpassed by the successor of the CDC 7600 in 1968. Part of the speed came from the computer's design, which had 10 small computers, known as the peripheral processors, funneling data to a large central processing unit. On March 1st of 1962, the LINC of Laboratory Instrumentation Computer offered the first real-time laboratory data processing designed by Wesley Clark at the Lincoln Laboratories Digital Equipment Corporation, later commercialized this as the LINC 8. Research faculty came to a workshop at the MIT to build their own machines, most of which they used in biomedical studies. DEC supplied components. To the image on the left, Digital Equipment Corporation introduced the PDP-8, which was the first commercially successful mini-computer. The PDP-8 sold for $18,000, one-fifth of the price of a small IBM 360 mainframe. The speed, size, and reasonable cost enabled the PDP-8 to go into thousands of manufacturing plants, small businesses, and scientific laboratories. To the image on the right, Hewlett-Packard entered the general-purpose computer business with the HP 2115 for computation. To the image on the left, Hewlett-Packard announced the HP 35 as a fast, extremely accurate electronic slide rule with a solid-state memory similar to that of a computer. The HP 35 distinguished theirself from the competitors by their ability to perform a broad variety of operations to store more intermediate solutions for later use, and to accept and display entries in a form similar to the standard scientific notation. To the image on the right, the Micrel was the earliest commercial non-kit personal computer based on a microprocessor, the Intel 8008. Thai Truong developed the computer, and Philippe Cahn, the software Truong, founder and the president of the French company R2E, created the Micrel as a replacement for many computers in situations that did not require a high performance, selling in the market for $1,750, more of appliance adoption. The Micrel never penetrated the U.S. market in the 1970s, but Truong sold Micrel to Bull. On September 4th of 1973, the TV typewriter designed by Don Lancaster provided the first display of an alphanumeric information and the ordinary television. They used $120 worth of electronic components as outlined in the September of 1973 of radio electronics. The original design included 2 memory boards and could generate and store 512 characters as 16 lines of 32 characters. And a 90-minute cassette tape provided supplementary storage for about 100 pages of text. For the image on the left, researchers at the Axiros, Palo Alto Research Center designed the Alto, which was the first workstation with a built-in mouse for input. The Alto stored several files simultaneously in Windows, offering menus and icons, and could link to a local area network. Although Axiros never sold the Alto commercially, they gave out a number of them to universities. Engineers later incorporated this feature into the workstations and personal computers. To the image on the right, Scalby advertised the 8H computer, the first commercially advertised U.S. computer based in the microprocessor Intel 8008. Scalby aimed in the 8H, available both in kit form and fully assembled, at the scientific, electronic, and biological applications. They had 4 kilobytes of internal memory as a cassette tape, but both teletype and oscilloscope interfaces. In 1975, Scalby introduced the 8B version with 16 kilobytes of memory for the business market. The company sold about 200 different machines, but they lost about $500. On June 14th of 1975, the January edition of the popular electronic feature in the Altair 8800 computer kit, based on the Intel of the 8080 microprocessor on the cover. Within weeks of the computer's debut, customers inundated the manufacturing company MIT's with orders. Bill Gates and Paul Allen licensed BASIC as the software language for the Altair. Ed Roberts invented the 8800, which sold for $297 or $395 with a case, and coined the term personal computer. The machine came with 256 bytes of memory, which was expandable to 64K. The visual display module on the upper left-hand image, the VDM prototype designed in 1975 by Lee Felsenstein, marked the first implementation of a memory-mapped alphanumeric video display for personal computers, introduced at the Altair Convention in Albuquerque in March of 1976. The visual display module allowed use of personal computers for interactive games. Or upper right, for the image on the upper right, Tandem Computers tailored its Tandem 16, the first fault-tolerant computer for online transaction processing. The banking industry rushed to adopt the machine, built to run during repair or expansion. On the lower left image at the bottom, Steve Wozniak designed the Apple I, a single-board computer with specifications in hand and an order for 100 machines at $500 each from the Byte Shop. He and Steve Jobs got the start in their business. In this photograph, the Apple I board, you will see the upper two rows are the video terminal and the lower two rows are the actual computer. The 6502 microprocessor in the white packet sits on the lower right. About 200 of the machines sold before the company announced the Apple II as a complete computer. Thank you all for processing. June 14th, 1976 was the Cray 1 on the lower right-hand screen. The Cray 1 made their name as the first commercially successful Victor processor, the fastest machine of their day. The speed came from partially of the shape, a C, which reduced the length of wires and thus the time signals needed to travel across them. The project started in 1972, yet the project completed in 1976. The speed was 166 million floating. On the upper left image, the Commodore PET, which was Personal Electronic Transactor, was the first of several personal computers released in 1977 and came fully assembled, as was straightforward to operate, with either 4 or 8 kilobytes of memory, with 2 built-in cassette drives and a membrane chiclet keyboard. On the upper right-hand image, the Apple II became an instant success when releasing in 1977 with its printed circuit motherboard, switching power supply, the keyboard, the case assembly, manual, game paddles, AC power cord, and cassette tape with the computer game was a breakout, especially when hooked up to a colored television set. The Apple II produced brilliant color graphics. On the lower left image, June 14th of 1977, the TRS-80. In the first month after the release, Tandy Radio Shack's first desktop computer, the TRS-80, sold for 10,000 units. Well, more than the company's projected sales of 3,000 units for 1 year. Priced at $599.95. The machine included a Z80-based microprocessor, a video display, 4 kilobytes of memory, basic cassette storage, and easy-to-understand manuals that assume no prior knowledge on the part of the consumer. On the lower right-hand image was June 14th of 1978. The VAX 11 and or 780 from the Digital Equipment Corporation featured the ability to address up to 4.3 gigabytes of virtual memory, providing hundreds of times the capacity of most mini computers. The Atari introduces the Model 400 and 800 computer. Shortly after delivery of the Atari VCS game console, the Atari designed two microcomputers with the game compatibility. The Model 400 and the Model 800. The two machines were built in the idea that the 400 would serve primarily as a game console, while the 800 would be more of a home computer. Both sold very well for appliance adoption. Although they had technical and marketing problems and faced strong competition from the Apple II, Commodore PET, and the TRS-80 computers. Adam Osborne completed the first portable computer, the Osborne 1, which weighed 24 pounds. For the upper left-hand image, the Apollo computer revealed the first workstation, the DN100, offering more power than some mini computers at a fraction of the price. Apollo Computer and Sun Microsystems. Another early entrant in the workstation market, optimizing their machines to run the computer in intensive graphic programs and common engineering. On the upper right-hand corner is the Commodore that introduces the Commodore 64, the C64 in other words, as that was better known, was adopted for $595 and came with the 64 kilobytes of RAM and featured impressive graphics and thousands of software titles, which were released over the lifespan of the C64. By the time the C64 was discontinued in 1993, and was sold and or adopted more than and was recognized by the 2006 Guinness Book of World Records as the greatest selling single computer model of all times. On the lower left-hand corner, Comrade Computer Corporation introduced the first PC clone that used the same software as the IBM PC. With the success of the clone, Comrade recorded the first year sales of $111 million, the most ever by an American business in a single year. On the lower right-hand image was the Apple computer that was launched in the Macintosh, the first successful mouse-driven computer with the graphic user interface, with a single 1.5 million commercial during the the lower right-hand corner image was the Apple computer that launched the Macintosh, the first successful mouse-driven computer with a graphic user interface, with a single $1.5 million commercial during the 1984 Super Bowl, based on the Motorola 668,000 microprocessor. The Macintosh included many of the least features at as much more affordable price of $2,500. On June 14th of 1988, Apple co-founder Steve Jobs, who left Apple to form his own company, revealed the NEXT, the Next, which was the computer he created then failed, but was recognized as an important innovation. At a base price of adoption for $6,500, the Next ran too slowly to be popular. The significance of the Next rested in the place of the first personal computer to incorporate a drive for optical storage disks and a built-in digital signal processor that allowed voice recognition and object-oriented languages to supply programming. Wow, that is incredible! And slowly in future development, with one step by the other, they had advanced to be where they are today. Yet you could always look back to where things started. And we want to give a big thank you and a special thank you to timetoast.com for having the history of computers. Available on their website. Again, a special thank you to timetoast.com for having the incredible history of computing available in an organized manner on their website. Stay healthy, stay clean, and stay safe. And we pray that you all had learned something new today. On today's episodes with Kaylan, better known as Professor Cygnus and Angels. Stay healthy and invest wisely. And always remember that all things in life have development.